this is the idea of what you have on your paper. You have a scale, and yours is like this, right? It's not doing this, so yours is equal, not unequal. So when it's equal, let's review a big idea. There's actually things in here right now. If I were to take something off one side, show with your arms what would happen. Take something off this side. Okay. Yeah, it would become unbalanced. Prove it. Okay, so if you've never played with the scale, there's proof that's what happens. And this is a lot of what happens in life, where you change one thing and everything burns out or blows up or whatever. So the idea of things being equal is pretty profound, and it's realistic. So what was a way we could take something off one side and not get it to be imbalanced? Do you remember that idea?
Take the same thing off both sides.
Okay. And today you guys are going to be using these blocks, and they're a little confusing because they actually have a real life weight. If I take one block off both sides, if I take one weight off both sides, one of these off both sides, even though they have different numbers on them, they actually weigh the same. They don't change in weight when I flip it. It's not like it's 2 ounces when I flip it. It represents 4 ounces. It represents 4 ounces. It doesn't literally weigh 4 ounces. So for now, if I take the same thing off both sides, which I just did, it stayed balanced. Now this thing's a little bit off balance, just a little bit, but not too bad. Really, it's off balance when I add something to one side, and then you know it's truly imbalanced. All right. So we could also add the same thing to both sides, and then it gets balanced. That's the big idea. You discovered that Friday with a real-life example. Today, these pawns, these in your paper little triangles, these are going to represent, can you guess?
X.
I guess they're, what was the object on Friday that these kind of represent?
The unknown.
The mystery box, yeah. Question mark on it. How do you hide weight in here? I don't know. Maybe you imagine like a little door that opens up and you can hide a weight inside there. That's kind of the idea behind this. So this could weigh, if this one weighs 3 ounces, and the same problem, if I'm on problem 1 and problem 1, this weighs 3 ounces, guess how much this one would weigh in the same problem? 3, yeah. It's the same rule that whatever I hide in one of these, I have to hide the same weight in the other one. So that's one of the main rules of the game. We're trying to figure out how much is in here. There's all kinds of strategies. Today you're going to start diving into these strategies and using these. We're going to do this one page, the front and back. And I think a lot of you will get most of it done, if not all of it done in class, and you'll not have any homework. But the point of this activity isn't to say, try to get this down kinesthetically and once you think you kind of have it down, just, quit using the kinesthetic pieces. Because if that was the case, many of you would say, I don't want to use them at all. I'll just solve these. I'll write this as an equation and solve it. Lesson 2 in the back. Don't go solving it using equation methods. I'm not after whether you have a doorway that works pretty good for you to get into the house. I want you to learn other ways of understanding it, because all the research shows the more pathways you have into the house to solve a problem, the better you understand it. And if you understand something, guess what the next level of understanding is, of like knowledge. After you understand something, what do you do with understanding? You do what? Yeah, and really you apply it to things. And so have you ever heard someone say, I just don't write story problems? What they're really saying is, my understanding, I have one way into the house, one way to solve the problem. I don't always know why I'm doing what I'm doing. I kind of memorize these visual steps, and I can get by, get the worksheet done, but don't give me those story problems. Don't ask me to apply it to real life things, because you don't ever go from sand to applying it. You have to understand it well. They're the same. Have multiple pathways of understanding. Kinesthetic roadway built up in understanding. And then those students will apply it the best to weird situations. So that's what we're after. Are you guys ready to dive in? Go ahead and set up problem 1. On your board, we're going to kind of build some language for your brain. And for some of you guys, this is like, oh yeah, this is coming back to me. For many of you, I've never seen this before, and we'll show you. So I'm going to use this so you guys can see what I'm showing up here. This is what you should probably be showing as well. And as you guys want to compare your board with mine, this is pretty much the same image as yours. And so there's 2 sides, and really we could draw an equal sign in the middle here. So we have like 2 pawns balanced with problem 1, 10-pound weight. Now, technically this thing's always balanced, but if I randomly make an illegal move, oh, you might see me do this, oh, to symbolize the fact that if this could move, like that one, then it would be moving and not be balanced anymore. But for now, it's balanced. As long as they show you a picture and if they started out and it's sitting on here, you can assume it's balanced. So whatever the pawn equals, whatever the triangle equals, you know it's a number that makes it balanced. I think many of you probably already looked at that and just said, boom, I know the answer. What did you think of? 5. Let's go ahead and write it in there. So here's the big idea. 5 plus 5 would have to be equal to 10. So you were saying if this side's 10, this side has to equal to 10. Ideally, you want each problem we do on this over the next 4 days, and we'll get a little more complicated, but you want every problem to be like, oh, that just makes sense. You don't land there, you don't start out at that point, but you eventually want each problem to just make sense to you. And to the point where it almost seems a little like easy. Like, this is like you teaching me to ride a bike. That would be so boring because I already know how. It just makes sense to me. Okay, today though, we're building the language to help us solve harder problems and maybe more than solve them, actually understand them in a real deep way. So, for these the format of these worksheets, and then you can start flying ahead of us as you go through these. Basically, what you're saying when you check these is you're saying the triangle is the same thing as x. In this case, we're saying it's 5, so we put our answer there. We say x equals 5. And then when we check it, we're basically taking the picture and we're putting what we think the triangle is equal to right there where the triangle is. We're replacing the triangle or the x with 5. And then we just say, okay, is this true? Well, if it's true, this should add up to equal each other. And in this case, we write it out over here. This is how you show your check step. I'll be walking around today to make sure you guys show up your check steps correctly. There's one other thing, especially on day 1. There's one other thing that we'll mention later about checking your answers. And I think it'll show up right over here on this one. For now, you just take the original problem, you plug in your answer. Go ahead, solve another one. This front page is really designed to guess and check, and also to explore a little bit what it might look like to use some shortcuts. So some of you that see the shortcuts, you can start using those. Alright, so you're setting up number 2, solving that real fast. We're just going to work our way right through some of the more complexities of this. Okay, so this side is 9 pounds. This side would have to be 9 pounds. Some of you did something in your mind that you don't even know how to show kinesthetically. Maybe some of you do that. Let's hear your answer, and what did you do? If you show me something kinesthetically you could do to get that answer. What did you have? Good. How many of you guys actually just said, well, what number plus 2 gives me 9? You just got 7. You just thought of that. Good. Some of you, though, potentially even were thinking a little more advanced. You're saying, really, what does this need to equal? So if they have 2 ounces in common, let's take 2 ounces off both sides, which would make this not 9, but 7 to keep it balanced below. And then, hey, what's left is equal to 7. You know it's 7. You could do that. You don't have to. Just look at it and kind of guess and check. So 7 plus 2 is equal to 9. Check mark. By the way, we're going to take about, 3 weeks worth of hands-on equation lessons and boil them down to about 4 days. So Monday through Thursday, we're going to try to tackle these kinesthetic roadways, and then we're going to move more to the traditional one, that we're going to move a little quicker through that, knowing that you built a deeper concept behind it all. So when you check this, make sure you plug in 7 where you saw the triangle. There was a triangle there was a block. It's equal to 9. You'd say check mark. Well, I plug 7 in for the triangle. It works. You don't have to draw the shapes over, by the way. That's just doing that. The first 2 solved really quick. The third one, sorry. Some students don't solve quite as fast. They might say, maybe it's 1. 1 plus 1 plus 3, would that equal 7? They say no. So that some people start guessing and checking. They start saying, let's try 2, let's try 3. You can do that if you want. How many of you guys have an answer for 3 already? Let's see what you got. 1, 2, 3. 2. And we can check that. 2 plus 2 plus 3 does equal 7. So, good job. We start to go pretty fast. Some of you might have even used the idea. Did anybody think of minusing 3 and saying, well, really, the 2 need to equal 4? Is anybody thinking that way? Some of you maybe thought that way and didn't write it, but you could do that. You could take 3 ounces off both sides. Cool. Problem 4, guessing and checking could take you a while. Does 1 work? I don't know. 1 plus 8, does that equal 1 plus 1 plus 1? How about 2? Does 2 plus 8 equal 2 plus 2 plus 2? Does anybody have a faster way? Let's set this one up and let's just talk about it a little bit. A faster way to solve this, because ultimately we're switching to faster ways. So Kaya, what would you do?
Take a pawn off each side.
Okay. Now just to play devil's advocate here, if somebody was like, take a pawn off if you use here, what would happen if you do that? Okay, yeah, that would get wider and it would be unbalanced. Whoa. So she said something pretty profound. She's saying take one off both sides, which if you're new to this, you would say, why are you doing that? Does it make sense? How do you know? You don't even know what's in there. How do you know you can take one off both sides and still be balanced?
X's are the weights the
They are the same. So because they weigh the same, I mean, if this one's 5, this one's 5, whatever they weigh, they would still be balanced. By the way, I can prove that. These actually do weigh the same in real life. So if I took off one, it's definitely imbalanced. But if I took off both at the same time, it's still balanced. Because they weigh the same in real life, actually. Wow, that's tremendously easier. 2 of these are equal to 8. Have you noticed how easy it is to solve them when you get all the pawns on one side? I mean, when you just get it down to pawns on one side, number of cubes on the other side, you barely think about it. In fact, you really just divide, right? What 2 things add to give you 8? 8 divided by 2 is 4. Okay. As far as checking your work, we need to have, like, if you're about ready to fly through the rest of lesson 1, or maybe you already are, but we need to have like an official pause moment. I'm going to purposely make a mistake, and I need you guys to catch it, and then we'll maybe with conviction understand why we're going to be picky about something and reject stuff. So here we go, official pause moment, hard to do when you're getting in the zone. Everyone pause, I need to show you something. Here we go. So let's imagine I took pawn off both sides, and, oh, this is not a good example. Let me try problem 5 actually. Let's say I took 2 off each side. All right, so I take 2 and then I have, oh, this is not the best example either. Let me try this. Let's imagine I took 1 off both sides, and now I have triangle, triangle, and then let's say a 3, and then I get 1.5. Now, right now, a lot of you are thinking, who would do that? But just hang on 1 second. So imagine, I think it's 1.5, and then I go check my answer, which checking your answer usually helps you know if you make a mistake, right? 1.5 plus 1.5. If I plug that in, I would say, okay, 1.5 plus 1.5, that equals 3, check mark. I get it right, I've checked my answer, I know it's right, my neighbor checks his answer, and he's getting like, that's not what I got, and I checked mine too. Why did checking not catch her problem, I guess is my real question. You know the mistake, but do you know why I'm checking my answer, plugging it in, didn't catch my mistake? That doesn't, I mean, what do you know to you?
Because it should equal 4. Both sides should be equal.
Well, when I plugged it in right here for the triangle, it works. Triangle plus triangle equals 3, it'd be 1.5. So why doesn't checking my answer work? I thought that always was going to catch my mistake. Okay. How could checking my work have caught that this was a wrong answer? I did something in my checking that was unusual. You know?
You added instead of
Okay, you're saying something was solving it maybe? What can I do to check my work to make sure I catch my right?
You check with the original statement, not what you came up with.
So you're saying if I change the problem, I could get an answer that makes the new one work, but it may not work in the original problem, because I may have changed the problem incorrectly. That makes sense. I think what we're saying here is when you check your answer, you may get problems that are huge, and you reduce all these things, cancel all these things out. Now let's just say it together. When you check your answer, you should plug it into where?
The original.
The original problem. When you check your answer, where should you plug it into?
The original.
And if you don't, we're going to say, problem's wrong. But I have the right answer. We need to encourage good philosophy here of checking answers. You can't check your answer in the modified problem. You have to use the original one. Otherwise, you don't know if your modified problem is actually modified correctly. So the answer may work for that one, but not for this one. If I plug in 1.5 here, and this is Dylan, you were trying to say that basically it wasn't going to work. he's right. I made a mistake when I was modifying the problem. So check your answer in the original problem, and you'll know if your answer really works. So over here, I should see my real answer. What'd you guys get for real on 5?
1.
1, okay, so we can check that one in the original one. So to check it in the original one, even though I may have crossed out 2, I don't have to, but if I did, great, but I can't plug it into this one. Potentially I made a mistake, so I should go back to the original one, the one that for me is in black ink, the picture, and go to 1 plus 1 plus 2, and check it there. All right, question?
Then how number 4? So you have 4 plus 8,
Uh-huh.
then 4 plus 4 plus 4.
That would be 12. So that would work, that would be 12 equals 12. Right?
Yeah.
I guess so. Seeing it funny, you're fine. 4 plus 8, 4 plus 4 plus 1. We can. Okay. But that's lesson 1 in a nutshell, and you guys can continue either guessing and checking, or maybe you just go ahead and reduce things down and solve it way faster. By the way, how much weight is this right here?
14.
Okay, some students in other classes are thinking 104, but don't do that. This is supposed to represent 10 pounds and then a 4 pound, or ounces, I guess. 10 ounces and 4 ounces would be 14
We did
ounces.
this.
How many guys are ready to look at the back page, like the front page, you do it okay on? All right, why don't we just as a class show you that so we're not holding you back. Here's lesson 2. Each lesson is usually going to have a review below it. If I skip the review, it's because I felt like it wasn't necessary yet. And so you can see I actually manually copied and pasted other lessons, sometimes together, literally cut them and then copied them on a copy machine so that they're combined. So this is lesson 2, down below is lesson 4. Apparently lesson 3 didn't have something very significant, so I just thought we'll skip it or it will naturally get included in the next lesson. So there's something from each lesson, and on this lesson, the big takeaway is you learning to connect the dots the other direction from the algebraic statement. Algebra is like when numbers and variables decided to hang out and go like, why are you together? They're supposed to be, English class and math class, what happened? So this is algebra, and we're trying to go from this to the kinesthetic and the visual side of the brain. We want both. So we need to write something in here. Because honestly, you may not always have the kinesthetic option when you're at home doing these papers if you don't finish them. So we're going to say in general that you want the credit, we need you to build some pathways on the visual side of the brain and the kinesthetic side of the brain. So we want you to draw all these pictures, okay? I'm getting ready to walk around just a little bit to make sure everyone's solid on drawing these and solving these, so make sure you're with us. Okay, let's give it a shot. By the way, 2 times x, we need to be really clear on this with a real quick maybe side example. If I gave you this little rectangle and said, what's the area, the fastest thing you could type in on a calculator if you had to use it would be what? Okay, so you're not going to type in 1 plus 1 plus 1 plus 1 plus 1 plus 1. So that's out of the books, but maybe 3 plus 3, that's 3 buttons. Or some of you might say 2 times 3, and you could type in either. Because multiplication is what? Repeated addition. Hey, multiplication is what?
Repeated
Addition. You got to know that with confidence. So when you see the dot, it's condensing something down. Something's repeatedly being added. And when you, if I wanted to, I could just call this 3 and x, right? And so we really could say this, that 2x is condensed. What is it condensing? What do you have 2 of? Yeah, 2 of the x's repeatedly being added. So it kind of makes sense that for us right here, we should be picturing what? A number 2 block, what are we picturing? 2 x's, which are 2 of the triangle. That's the big idea for this lesson. When you draw this, make sure you don't put a 2 cube, which some people do. Some of you may be helping other people on this homework some days, even if you say this is kind of easy. Maybe for you, it's learning what am I going to see other people get confused on. Now, I'll just tell you right now, if you're not a kinesthetic learner, you may get confused. Why didn't I put a 2 cube? Why are we not putting a 2 ounce weight? This is 2 dot x. This means you have 2 x's, x plus x. And that's a huge, big idea. Hey, go ahead and solve it. These aren't too hard to solve on lesson 2 once you draw your picture. So 2 x's, and x and a 3. You would say, hey, take a pawn off both sides. You got a 3. Go ahead and try solving another one if that was pretty easy for you. Make sure you plug it in. You plug it into the original problem, so 3 plus 3. That equals 3 plus 3. Check mark. A huge part of your 9 weeks grade for this first 9 weeks will be the equations test. And we'll move into decimals and fraction equations as well, and we'll have to get those down eventually too. So understanding these really concretely will help us apply into all kinds of real life story problems. That's why we're building this up so strong. Great question was asked. Can we just go ahead and put 2 times 3? Like, can we condense it back or leave it in a way how it was originally written? You betcha. So if they give you like 5 x's, you don't need to put, pretend x was equal to 6, you don't need to put 6 plus 6 plus 6, you can just put 5 times 6. So in other words, you can plug it into the original algebraic statement if you want. All right, try setting up number 2. We'll tell you in a moment if you're setting it up right. Go for it.
How would you draw these 3 dots? That'd be 3 x's. So that'd be, but x is also the same as mine. And we have 3 x's, which is drawn pictorially as 3 triangles.
Okay, if you got an answer for 2, let's shout out what you got. 1, 2, 3. 2. Sounds great. So 3 x's would be 3 triangles. You should have that drawn. It's okay to feel like a little confused today. There's some of you that would say the concrete side is actually a struggle for you sometimes, and that's okay. But still draw a picture down, and then just individually get your individual questions answered, because a lot of times your questions are very unique to what you're confused about, and you need a unique answer, a catered answer to your question. So write it down, work it out, and then put a star and say, how did you get that picture? How did you know to cross that out? And ask those individual questions, because a lot of times you're just looking down when we're explaining something, and then you're confused the rest of the lesson because I was looking up right when you showed that, now I'm confused. So yeah, if you needed help on 2, if you were one of those people that maybe weren't so sure you had it right, it looks like you could take a pawn off both sides, and you have 2 of these triangles equal to 4, so then each would be 2. So if the triangle is equal to 2, 2 plus 2 equals 4. You check that in the original statement, so you have 2 plus 2 plus 2 equal to 2 plus 4. Check mark. Anybody want to try a problem from the ones down below, a little bigger? Which one? Okay, you're saying you'd help us on one? Okay. Which one does someone want throwing out there that we should try? Let's just try 4 maybe. That's good. Big idea of problem 4, of lesson 4. And it may not seem big, but I'm telling you, as someone that's taught this without concrete representation of equations, this confuses people. What you're about ready to do seems so small, but for many students, I mean, I've taught calculus students that didn't understand whether you could subtract an x or whether you could just combine them. So look at this real quick. This is a big idea of problem 4. X, you have an x, you have a 2. And when I say I've taught calculus students, they get confused on this. I mean, they've memorized it. They were a pro at one time, that's how they got to calculus, but then they forget it because they don't understand what they're doing. So the question people would have is they would do stuff like this. They would say, well, let's take an x off both sides. That's what they would do. What's the problem with doing this when you look at it on a scale? Do you know what the problem is, Lindsay?
That's the same side.
Exactly. You took an x off both sides of what? You know, here's the equal sign, so you just taking 2 off this side would have made it really imbalanced. And then here's the crazy thing. When you tell them that what you should really do is take the x and the 2x and say you have how many x's on one side? 3. And that blows people's mind. But when you see it visually and you say, well, hey, if they're all sitting in the same cup and you just rearrange them, does it change their weight? And people go, well, of course you can rearrange them. That's not going to change the weight. It's still the same problem. So it's pretty powerful to use a concrete representation of these because you really can just move things close together and say, look, you really have 3 ponds or 3 triangles being totaled up on this side. Big, big idea. All right, so you can take one off both sides. Let's see, Landry, do you want to solve this one? Tell us, what would you do?
I would do one on both sides.
Okay, take a pawn off both sides when they do that.
And then I would take both 2 sides.
Okay, so you're going to take 2 ounces off each side. Minusing 2 from both sides. And now you have a total of 10. Some of you that are very visual, you're going to go crazy when you start reducing big equations, big pictures. You're going to look at these pictures and think, oh, I've had students do this. I don't get any of this. Oh, it's just a big jumbled mess, and they're confused. Understandably, I look at that and get a little confused because it's like, well, wait, what's left? Especially if you're using all the same color, pencil. So I would recommend this. After you've canceled things out, look at each side and say, what's really left over there? And then rewrite it or redraw it and just say, look, here's all that's left. 2 ponds are equal to 10. Sounds like problem 1, they'd all be 5. Is that what you would do?